So area, so what will be the area? Then you can see now area is equal to d4 minus d2 into c. So d4 minus d2 into c will give the cross section area. Therefore what will be shear stress? Force upon area. How much force is acting? P upon area is on double side, that means on this side as well as from back side. So we are getting twice of d4 minus d2 into c. So P is equal to tau into 2 d4 minus d2 into c, where c is the clearance. Okay, where c is the thickness. Okay, now next is crushing failure of the spigot end. So see the diagram here, crushing failure. So crushing failure is nothing but like compressive force or compressing force, that's why it is called as crushing one. So here you can see now, this is the spigot end, and whatever portion of the cotter goes inside, that will go under crushing. That means on this end of the spigot, on this end of the spigot where the spigot is experiencing the crushing failure. Okay, so sigma c is equal to p upon t d2 is your crushing area, t into d2 will be your crushing area. So that will be equal to sigma c is equal to p upon t d2. Crushing failure of the socket end as shown in figure. So if we see the socket also, that will also undergo crushing failure. Crushing failure is equal to, then area will be equal to, what will the area, cross section area, d4 minus d2 into t. So sigma c is equal to p upon d4 minus d2 into c, that will be the crushing area. Next is bending failure of the cotter when cotter is tight in the socket and spigot. So there are two things you must try to understand here. So we are having cotter. Okay, I will go to the previous diagram, and in the diagram we will see spigot and our assembly will see. So we can see this. Okay, fine. So this is our spigot and here is our joint. Okay, so spigot and socket when inserted in each other, then cotter is inserted through the slot. Okay, that is clear to you. Now if cotter is loose inside the socket and spigot, when cotter is loose inside the socket and spigot, at that time bending stress will be observed by the cotter. Bending stress will be observed by the cotter. Okay, are you getting my point? That means this will undergo bending. But when joint between cotter, socket and spigot is very tight, if it is press fit, not loose fit, if it is press fit, then it will undergo shear stress. This is very important. If in the problem they are saying it is loosely fitted, then we must calculate bending stress, and if it is tightly fitted, then we must calculate some shear stress there. Okay, so we'll again go to our list of formulas, then we'll see how failure takes place. Okay, yes, so here if we see, yes, bending failure of the cotter, when the cotter is tight in the socket and spigot, it is subjected to the shear stress. When it becomes loose, bending occurs. The forces acting on the cotter are shown in figure. Okay, so you can see the figure now. Okay, so in this case cotter is made horizontal, you can keep it vertical also, and then you can do the analysis. Okay, then you can do that, both ways are correct. Then what will be the amount of stress generated? Sigma b is equal to p by 2 d2 by 4 plus d4 minus d2 by 6 into b by 2 upon tb cube by 12. For this equation we are having small derivation, that derivation we'll see afterwards. Right now we are just seeing the mode of failure of the component, failure diagram and stress equation. That's why we have gone through this, but for this we have to actually understand how this equation is being derived. So the equation derivation is very simple. Simple bending theory is used. Okay, and shear failure of the cotter already we have seen. Shear failure of the cotter already we have seen. So where is the shearing failure of the cotter?